Hello everyone. In this video, we will be discussing the atmosphere. If you look at the slide, you'll see a profile or cross-section of the atmosphere. You can see that its characteristics change between the surface and the upper atmosphere. Some of these changes reflect the properties of the gases that compose the atmosphere. Other changes reflect the physical properties of the atmosphere itself, such as temperature, pressure, density, and the effects of the force of gravity. The atmosphere's chemical and physical characteristics produce its layered structure shown in the slide. Gravity compresses air, making it denser near the Earth's surface. As you can see in the slide, the atmosphere thins rapidly with increasing altitude. In terms of chemical composition, the atmosphere has two broad regions, the heterosphere and the homosphere. Gases in the homosphere are well mixed, while gases in the heterosphere are layered by density. This slide shows the amounts of gases in dry, clean air in the homosphere. These gases are considered stable gases because the proportion of gases does not vary much. In terms of just the stable gases, the atmosphere is made up of the following: 78% relatively inert nitrogen, 21% oxygen, less than 1% argon, and 0.04% carbon dioxide. Based on temperature, the atmosphere has four distinct temperature zones: the thermosphere, mesosphere, stratosphere, and troposphere. The thermosphere roughly corresponds to the heterosphere. The thermosphere is a region of very low air pressure, few molecules, and high temperatures. Intense solar radiation in this portion of the atmosphere excites individual molecules to high levels of vibration. The temperature profile in this slide shows that temperatures rise sharply in the thermosphere to over 2,000 degrees Fahrenheit. Despite such high temperatures, the thermosphere is not hot in the way that you might expect, because temperature and heat are different. Temperature is a measure of kinetic energy, the energy of motion. Heat is the flow of kinetic energy from one body to another and depends on density. The actual heat in the thermosphere is small because there are so few molecules. Heating increases near Earth's surface because the greater number of molecules in the denser atmosphere transmits their kinetic energy as sensible heat, meaning that we can measure and feel it. The mesosphere is the area from 50 to 80 kilometers or 30 to 50 miles above Earth and is within the homosphere. At high latitudes, an observer at night might see bands of ice crystals glow in rare and unusual noctilucent clouds, which are so high in altitude that they still catch sunlight after the sun has set below the horizon. The stratosphere extends from 18 to 50 kilometers or 11 to 31 miles above the Earth's surface. Temperatures increase with altitude throughout the stratosphere. This warming is caused by ozone converting ultraviolet energy to heat. And finally, the troposphere, where we live. The troposphere is the atmospheric layer that supports life and is the region of principal weather activity. Approximately 90% of the total mass of atmosphere and the bulk of all water vapor, clouds, and air pollution are within the troposphere. The atmosphere has two specific functional zones, the ionosphere and the ozone layer, also called the ozonosphere, which removes harmful wavelengths from incoming solar radiation and charged particles. The ionosphere extends through the thermosphere and the mesosphere. The ionosphere absorbs cosmic rays, gamma rays, X-rays, and shorter wavelengths of ultraviolet radiation, changing atoms to positively charged ions and giving the ionosphere its name. The glowing auroras occur principally within the ionosphere. The portion of the stratosphere that contains an increased level of ozone is the ozone layer. Ozone is a highly reactive oxygen molecule made up of 3 oxygen atoms. Ozone absorbs ultraviolet energy and radiates longer wavelengths of infrared radiation as heat. The process converts most harmful ultraviolet radiation, effectively filtering it. Natural and anthropogenic pollutants in the troposphere are important topics of research in physical geography because they have serious human health implications. Pollutants are gases, particles, and other chemicals in the atmosphere that are harmful to human health or cause environmental damage. Some sources of pollution are natural. These sources include things like wildfires and volcanoes. Local and regional landscapes can also affect air pollution. Surrounding mountains and hills can trap and concentrate air pollution or direct pollutants from one area to another. A temperature inversion, as we see in the slide, occurs where the temperature of the atmosphere increases with altitude rather than decreasing with altitude at the normal lapse rate. Inversions can result from certain weather conditions, such as cool air blowing in off the ocean, or when the air near the ground is radiatively cooled on clear nights, or from topographic situations that produce cold air drainage into valleys. A normal temperature profile permits warmer and less dense air at the surface to rise, moderating surface pollution. When an inversion occurs, warm air from the surface rises, but it is trapped by the warmer air of the inversion layer. Anthropogenic air pollution is more common in urbanized regions and is responsible for roughly 2% of annual deaths in the United States, China, India, as well as Canada, Europe, and Mexico. As urban populations grow, human exposure to air pollution increases. Photochemical smog is formed by sunlight interacting with chemicals in automobile exhaust. Smog is the major component of anthropogenic air pollution and is responsible for the hazy sky and reduced sunlight in many of our cities. North American urban areas may have from 10 to 100 times higher nitrogen dioxide concentrations than non-urban areas. Nitrogen dioxide and water vapor form nitric acid. Nitric oxide molecules react with volatile organic compounds, such as hydrocarbons in gasoline. This reaction produces periacetyl nitrates, which are particularly damaging to plants, including agricultural crops and forests. Ozone is the primary ingredient in photochemical smog. The same gas that is beneficial to us in the stratosphere damages biological tissues in the lower atmosphere. Air pollution associated with coal-burning industries is known as industrial smog. Sulfur dioxide reacts with oxygen and water to make sulfate aerosols and sulfuric acid. Coal burning, electric utilities, and steel manufacturing are the main sources of sulfur dioxide. Sulfur dioxide-laden air is dangerous to health, corrodes metals, and deteriorates stone building materials. Sulfuric acid and nitric acid deposition have increased since the 1970s. Sulfuric and nitric acid deposition is a major environmental issue in some areas of the United States. Such deposition is most familiar as acid rain, but it also occurs as acid snow and as dust. Acid deposition is causally linked to serious environmental problems, declining fish populations and fish kills, widespread forest damage, changes in soil chemistry, and damage to buildings and sculptures. Okay, that's the end of this video. I'll see you in the next one.